Welcome to CARICOMP Insider, where high-tech facial recognition meets real-world intelligence.
A facial recognition algorithm scores 99% on its benchmark test. Then you feed it a real surveillance photo, grainy, off-angle, pulled from a compressed video frame, and that score plummets by 30 to 40 points. The algorithm didn't change, the photo did. That gap between lab performance and street performance matters to anyone with a face and a phone. If you've ever been tagged in a photo you didn't post, walked past a security camera at a mall, or unlocked your device with a glance, your face is already inside systems that rely on these accuracy claims. And if the idea that a 99% accurate system might actually perform at 60% on your image feels unsettling, it should. But understanding why that happens is exactly how you stop feeling powerless about it. Today we're going to walk through what benchmark scores actually measure, why they fall apart in the real world, and what a massive biometric ecosystem in India is revealing about the future of this technology. So why does a top-ranked algorithm choke on a surveillance photo? Benchmark tests evaluate an algorithm using high-resolution, front-facing, well-lit photographs, controlled lighting, neutral expression. No hat, no sunglasses, no motion blur. It's the equivalent of testing a car's fuel economy on a lab treadmill, a dynamometer, in perfect conditions. Your EPA sticker might say 30 miles per gallon. But on a cold highway with stop-and-go traffic, you're getting 22. That analogy comes straight from the research, and it's the clearest way to understand what's happening with facial recognition scores. The benchmark is the sticker. Your surveillance footage is the cold highway. Now, vendors publish those benchmark numbers because they come from clean lab conditions. And most buyers, whether they're a government agency or a corporate security team, never think to ask what happens after the image gets compressed, or shot from a bad angle, or captured in a crowd. According to performance evaluations comparing mugshot benchmarks to surveillance quality images, even market-leading algorithms can lose 30 to 40 percentage points of accuracy. Not fringe tools, the top-ranked ones. For someone reviewing a case file, that means a match they trusted might be barely better than a coin flip. For the rest of us, it means the camera at the airport or the stadium entrance might not be nearly as reliable as we've been told. And that accuracy collapse isn't spread evenly across everyone. Some algorithms show error rates up to 100 times higher on certain demographic groups compared to their headline average. 100 times? That single published accuracy number hides enormous variation underneath it. According to the Federation of American Scientists, data sets used for evaluation frequently lack demographic diversity. So an algorithm trained mostly on lighter-skinned faces might report 99% accuracy overall, while performing at roughly 60% on a person of color. That's not a rounding error, that's a different system for different people. And if you've ever worried about being misidentified, that worry has data behind it. What does this look like at massive scale? India's Aadhaar system now holds biometric data on more than 1.3 billion people. It's the largest biometric database on Earth. According to a recent market report from Demystify Biometrics comparing 32 vendors, success in India doesn't come down to who has the highest match score. It comes down to accuracy across diverse skin textures, performance under wildly different climates and lighting, low latency matching for high-volume authentication, and compliance with India's evolving data protection laws. A 99% match rate at a 1,000-person scale sounds impressive. At a billion-person scale, that same 1% error rate generates 10 million false positives. The number didn't change, the consequences did. And there's something subtle happening in that Indian market that signals where the entire industry is heading. The report found that competitive value is shifting away from raw matching algorithms. It's moving toward what analysts call trust orchestration. Basically, the ability to combine liveness detection, injection, attack resilience, regulatory compliance, and environmental adaptability into one system. The algorithm score is just one ingredient. The recipe is everything around it. India's market is evolving towards scenario-driven leaders rather than a single winner-takes-all champion. That means the question isn't which algorithm is best. It's which algorithm is best for this specific camera, this lighting, this population, this use case. The breakthrough isn't that benchmarks are wrong. Benchmarks are right, but only for the one specific scenario they measure. A 97% match on a clear enrollment photo is worth 10 times more than a 95% match on a degraded surveillance frame. But most people read those raw numbers backwards. So here's what to carry with you. A benchmark score tells you how an algorithm performs on its best day, with perfect photos in a controlled lab. Real-world accuracy depends on the image you actually have, the lighting, the angle, the resolution, and who's in the photo. The number on the label is not the number in the field. Whether you're evaluating evidence or just wondering how that airport camera sees you, the question was never, is this algorithm accurate? The question is, accurate on what? The full story's in the description if you want the deep dive.
Now you know something most people in this industry don't. Use it. And when you're ready to put it to work, caracomp.com. We'll see you tomorrow.